So in this video, I'd like to ask a question regarding special relativity, in particular about the twin paradox. And just a quick overview of the twin paradox. Basically, what the situation is with the twin paradox is when, let's say you have two people, right? Let's say they could be two twins or siblings, and one of them gets on a spaceship and goes on a long journey at a high speed, let's say half the speed of light, and one of them stays behind. So what happens is, so let's say one of them goes on the journey, like at half the speed of light for like a long distance, and then when they return, what they find is that the time ran slower for the person on the spaceship who went on the journey, and the time ran faster for the person on the Earth, meaning the person on the Earth aged more. So my question is in regards to frame of reference, and why is it assumed that the Earth is, like, say, the master frame of reference for all of these paradoxes? Why is the velocity always measured relative to the Earth rather than something else? And I'm going to try to demonstrate what I mean in the upcoming scenario that I'm going to try to show here. So my question is now, let's say if both people get on the spaceship and they go on the long journey, let's say they travel in a straight line for, let's say, half the speed of light. They decide to go on the journey, and so technically their time will still run slower, and the time on Earth will theoretically run faster. So let's say they leave the Earth, and so they leave the Earth behind for now, right? So let's say they're traveling along at around, let's say, half the speed of light in a straight line, and they see that they are approaching another planet close to the same speed, like half the speed of light. So let's say there's a planet right here, and one of these twins, one of these siblings, decides to get on a spaceship and start decelerating in order so that they could stop at this planet. So what my question is here is, let's say if one of these twins gets off of the ship. Let me take the small one here. Okay. Let's say that twin gets off the big ship and gets on a small ship and starts to decelerate to stop at this planet. He'll have to decelerate again to half the speed of light relative to the spaceship. So again, now my question is, whose frame of reference is like the main frame of reference? Like, whose clock will run slower and whose clock will run faster? That's my question, because if this was like a closed system based on this theory of relativity, then since this guy in the small ship is accelerating, his clock would theoretically start to run slower, and this person's clock would run faster, because now this is like the so-called stationary frame of reference, and this guy's accelerating away from it. But the only thing is that this planet and the Earth are technically kind of in the same frame of reference, because they were traveling in a straight line at half the speed of light, and they encountered another planet where one of them wanted to stop by. So, like, my question is, who's to say, like, which frame of reference is the main frame of reference, like the master frame of reference or absolute zero? It just seems to me that this theory implies that the Earth's frame of reference is absolute zero or something, and that all velocities are measured from the Earth. Like that's like a strange assumption to make, because like what's kind of ironic is they came up with this theory to explain the results of the Michelson Morely interferometer, where they were trying to find what the speed of the Earth was through the luminiferous ether. But in a way, what this theory implies is that the Earth is always at rest. So it's almost implying that the Earth is stationary relative to the rest of space, and that we have to measure relativistic changes based on speed relative to the Earth. But how do we know, like, that the spaceship is closer to the absolute zero of the universe rather than the Earth? So how do we know which direction is the zero frame of reference of the universe? So that's basically my question.